Okay, universe, here's my question. Is this working? Christine Cooney is on. Oh, Una, I love you.
She's on your live stream?
Yes, I have no idea if my live stream is actually working, but at least she's on. Hi, Una. My goal is twofold, if I can get this to work. Step 1, get the friggin' live stream to do the friggin' live stream. Step 2, can I do the live stream through my tablet? If I can, then I'm golden, because then I can start doing my tutorials, but I have to actually get there.
Image has noticed that you are on her live stream period. Please tell us that it's working.
don't know why I'm even having the headphones on. I'm not actually using it to hear anything. I'm basically having to
Need more water?
Probably.
So it's good to know that for me, making a video is super easy. Being able to upload it? Scheist! Scheist! Okay, it goes ready for the drying too.
Yeah.
And this is how it's going to work for the next 2 weeks. We're just going to be sitting on our computers waiting for things to either reply or get back to us or whatever.
Mm-hmm. $400. Mm-hmm. Eyes. It's more impressive in person.
the live stream working?
Ish. I'm pretending it is anyway.
I'm pretty much on a waiting game right now. I don't understand why my videos aren't playing online.
Mm-hmm.
So I have to wait for either Dr. Mackey or Mr. Wood to contact me.
Can you text Una to see if she can see what I'm doing?
Has she been responding?
I'm so focused on the live stream right now that I'm not
It's
even.
buffering but working now. So you can see what Laura's typing, question mark? The Google Drive that I shared with you, period. It should be colored purple, hopefully. So if you go under shared with me, comma, there should be an Algebra 1 folder with shared by Dubois there, with luck it's purple so you can see, period. So Christine can't see what you're doing.
Okay, good.
Good.
She can?
She cannot.
Shit.
Oh, there goes my phone. Video hasn't changed since displaying my yay I helped kind of comment. I can still hear you though. I can see something again. Quadratic formula.
Okay.
If you can hear us, that means we're going to have to sing.
Wait, she can hear us.
Apparently.
X equals opposite B, plus or minus square root of B squared minus 4AC, all over 2A. Oh my god, the sound is working. Huzzah, happy days, success! Ah! How long did this take me? Oh, I've been working on this for over an hour.
Did that get through, question mark?
Okay. Hello, universe. I'm going to pretend for half a second that you can hear me. I've been working with a friend to see if the live stream can be working. I am told maybe it is. Welcome to the Coronication. That's about the best way I can treat this, is to treat it as a joke and call it the Coronication. I had started doing some I had started doing some setup, and then found out nobody was actually seeing what I was doing, but this is what I did. So right now I am working in Algebra 2 Goal 4. All right, so for those of you who are watching the live stream, assuming any of you are, this is for Algebra 2 Goal 4. That's where the vast majority of my students are. At the moment, I can pull up the data, but I don't want to show data. There are two major things for Algebra 2 Goal 4 that you want to keep in mind. First is, you see on the left over here, you have that list of perfect squares 1 through 20. Yes, I know them all off the top of my head, but you are not me. You are not human calculators. You need to be able to know these numbers on your own. So I'm leaving the screen open deliberately so that, assuming you have your notebooks, you can actually copy this into your notes and use it as a reference. I know there's a couple of people who are in Goal 4 who already have it copied down in their notes. The second thing that you're going to want is the quadratic formula. I cannot write with the brush tool and live stream at the same time. The lag is insane. And so I am forced to do this via text. And so here, over here is the quadratic formula. X equals opposite b plus or minus square root of b squared minus 4ac all over 2a. And yes, my sister and I were twinning really hard. She's doing her own stuff for her own school. The question... oh my goodness, as I choke on myself. The question for the quadratic formula, it is hands down the most versatile formula. This is one of the big formulas for the SATs, and it's probably the most commonly used formula for the entirety of Chapter 4. What you need to know is when you look at opposite b plus or minus the square root of b squared minus 4ac, what the heck is a, b, and c? Well, a, b, and c are based on the assumption that your x squared is your a, your x is your b, and your flat number without a variable anywhere remotely near it, that is going to be your c. And I pulled from Alex, but apparently nobody saw when I was live streaming. What happens is, here's what you have. X squared minus 3x minus 10 equals 0. Very, very important. Always set your equation to 0. That's a staple for this chapter. If there is more than one solution, yada, yada. So what's our a, b, and c? What's our x squared? Well, there's nothing. It's blank, which means it has the invisible coefficient of 1. What is x? That is going to be the number in front of it, which in this case is negative 3. What is c? Negative 10. It becomes negative 10. From there, we use our formula, x equals opposite b plus or minus square root of b squared minus 4ac all over 2a. We take our a, b, and c's and we simply plug them in. So opposite b becomes opposite negative 3 plus or minus the square root of b squared, negative 3 squared, minus 4 times a times c. For those of you who are trying to do this on the calculators, FYI, be very, I see a mistake here. Be very, very careful with your parentheses when you have a negative number, because the calculator will mess you up and you're going to say, yeah, where did I get it wrong? Well, it's because parentheses are a thing, especially for regular calculators. I don't know what it would be like on your phone calculator. I'd have to actually think about that. But I'm assuming since you're on Chromebooks, you'll be using those calculators, right?
Right.
B squared minus 4 times a, which is 1, times c, which is negative 10, all over 2a, 2 times 1. And oh my god, when I look at it text, it looks scary. But the good news is that now we just order of operations the hoo-ha out of this. So first things first, opposite negative 3 is just 3. Negative 3 squared, like I said, if you were careful with your calculator, that's going to be 9. 4 times 1 is 4 times 10, and we can simplify that a little bit better. So that will be 3 plus or minus the square root of 9 plus, because negative times a negative is a positive, so that becomes 4 times 10, which is 40. And then 9 plus 4, that's 49. Gee, what's root 49 again? Let me scroll all the way up top here, that list of perfect squares. Is it there? Is it there? Ooh, 7 squared is 49. Interesting. All right, so then how do we actually go back? What is root 49? 7. So it becomes 3 plus or minus 7 over 2. And it's worth mentioning when we first started this, it looked like this ungodly mess. Look at all the parentheses, the square root, which I can't even draw because I don't have an equation editor in Photoshop, yada, yada, yada. And it looked so scary, but once you simplify it, it's 3 plus 7 over 2 or 3 minus 7 over 2. 9 times out of 10, especially in goal 4, these will level out pretty fast. What happens? That gives you 10 over 2, negative 4 over 2, which means your answer is either 5 or negative 4, which, when you scroll back up and look at the example pulled from the software, if there's more than one solution, separate with commas. It's almost like the software knew what was happening or something. Funny that. Now, the good news is this takes care of a laundry list of topics. Knowing the quadratic formula for Algebra 2 Goal 4, you're going to get a whole list of topics that will be taken care of. Let me show you which ones, assuming I can get this and work. I want to be in, not this screen. I want to be in this screen. Oh, my Lord. I have done so much logging out and logging in the last hour. It's kind of embarrassing. Come on, universe. Facepalm. Come on, I would like to sign back in, universe. Please be nice to me. Oh, my shiznits. Fine, we'll do it the long way. All right, when you are looking, anything that says factoring, although I do eventually want you to get used to the idea of factoring, that's going to be a different live stream if I'm dying a slow death on this hill. But anything that's done with factoring can now be done with the quadratic formula. So factoring can, let's see here, factoring a quadratic, factoring a quadratic, factoring a quadratic, all of that is quadratic formula. Factoring a perfect square trinomial, technically there's a shortcut for that, but if you can't remember it on demand, quadratic formula. Finding the roots of a quadratic formula, a quadratic equation. Quadratic formula. You see, that's like what? 1, 2, 3, 4, 5, 6, like 8 topics already. Solving a quadratification and simplification. We're going to talk about that one next. Solving a quadratic equation given the roots and the leading coefficient. That's another easy one. Where's the quadratic formula here? But anyway, just at a glance, you can do a bunch of these topics using just the quadratic formula. And since we're leading into the quadratic formula, I want to talk a little bit about how you can use the quadratic formula to simplify, or rather, how you can use algebra to simplify to get to the quadratic formula. Wish me luck, I'm going to try to screen grab something. So, simplification, where was it? Now that I know I can get this up and running, I'm going to be so prepared tomorrow for Coronication Day 2. Problem with need of simplification, there it is. Look at that unholy mess. Isn't it scary? Solve for x, sure, but how in the name of shiznits am I supposed to do that? The horror, the horror. Well, let's talk about that. Copy, done, here. Let's paste this. Let's zoom out a little bit. Where are my layers? Where are my layers? Oh. There we go. Okay, paste, transform. Let's make this a little bit bigger so we can actually read it. Can we all see that? I'm going to pretend that we can. All right, I have to use the text tool because, again, brush tool is evil. So, nope.
If we can figure out how to do it on the iPad will work better.
One miracle at a time here. Stop.
Yes.
Stop. Bad. Text. And now let's just make a box. Okay. When you're first looking at this, that x plus 1 quantity squared, that's the thing we want to look at first, because when they say simplification, what they want to do is they want you to FOIL this out in order to move it over to the other equation. Saying that out loud versus actually seeing it are two different things, so let me talk a little bit about this. When you have that x plus 1 quantity squared, when you have x plus 1 quantity squared, what that fundamentally means is that you have x plus 1 times the quantity of x plus 1. Now that should look familiar from a certain couple of topics in Gold 3. What this is FOIL. So we're going to use FOIL in order to do this. So first, outer, inner, last. Our first terms is x and x. So x times x is x squared. Then outer, x times 1. So that's going to be plus 1x. Then inner, 1 times x is 1x plus 1 times 1, which is just kind of, whoops, not exclamation point, Ms. Dubois, 1. That simplifies to x squared plus 2x plus 1, which is now equal to the other side of the equation, 2x squared plus 11x plus 21, which I need to space out to make that even remotely legible, Ms. Dubois. Now, the question you will hear me back in the real world, you know, when we're not all isolated in our tiny little houses, is that set to 0? I had said that earlier in the live stream. You always want to make sure with quadratics that your equations are set to 0. And very obviously, there is nary a 0 to be seen, like anywhere in this equation. And that's the part that we got to fix, quote unquote fix, is we have to actually take the effort to set, computer, be nice to me, set equal to 0. That's what we want to be setting ourselves up for. So what are we going to do? We're going to subtract our x squared. We're going to subtract our 2x. And we're going to subtract our 1. What we do to one side, we do to the other. So minus x squared minus 2x minus 1. When you do this out, I wish I could use the brush tool. My handwriting would be way easier to read than this Fizz widget. Okay. When you do that out, there's our 0. We were looking for you. Where have you been? What is 2x squared minus x squared? That's just x squared. Because if I have 2 x squareds and I take away one of them, I only have the 1. Now, what is 11 minus 2? That's going to be 9x. And then what is 21 minus 1? There. That is going to be 20. And look, even when I'm typing, I still write a plus instead of an equal sign, or an equal sign instead of a plus, whatever. And oh, look, we have an A. Technically, it's a 1. We have a B. And we have a C. This looks suspiciously like it's time for the quadratic formula, which is, sing it with me, x equals opposite b plus or minus square root of b squared minus 4ac all over 2a. See, I'm doing this over and over because it's funny. And since you guys can't actually respond to me, I'm thinking you're laughing. Anyway, so x equals opposite b. So that's going to be negative 9 plus or minus the square root of, what are we looking at? We have 9b squared, which is 9 squared minus 4 times a, God, I can't type, 4 times a times c, which is 20, all over, can I just write collectively over 2 times a? Will that be okay for you guys rather than me trying to write out all of that hyphen, 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 hyphen? I'm going to pretend that it is. It's still visually messy to read, but again, the order of operations will make life easier for us. So that's going to be negative 9 plus or minus the square root of what? 9 squared is 81, minus 4 times 1 is 4 times 20 is 80, right? All over 2, which means, extend this a little bit, equals negative 9 plus 1 all over, so now I can simplify this a little bit more and put in the parentheses, over 2, over 2. Oh my Lord, Miss Dubois, do the thing! Over 2. So what is that going to actually get us? That is going to get us negative 9 plus 1 is negative 8 over 2, or it's going to be negative 9 minus 1, which is negative 10 over 2, which, over, Ms. Dubois, over. over 2, which simplifies to -4 and -5. There you go. There is our factoring. Let's see here. Again, everything is set up. The equation itself looks scary, so long as you remember your FOIL, set everything equal to 0, and then you can use your quadratic formula. Those are the key things for Chapter 4, and that's a bunch of stuff for the chapter. There is a few other things that I want to talk about, but I've been so focused on the Algebra 2 people, and I now want to talk about Algebra 1. There are some things for you guys that you need to work on, that you need to be aware of, and now I want to kind of switch gears, which means I'm going to be turning off a whole bunch of our... Nope, that didn't work. Why did the thing not do the thing? Oh, because sensei baka no sensei.
バカじゃないわよ。
Baka janai da yo. Baka da yo.
じゃない。
Keep telling yourself. Okay, so this I have to do as separate thing. Okay. So now, new text box. And now we're on Algebra 1, Goal 4 for our communication. Let me switch over to the other course and see what kind of topics we're going to be needing. So this is for Algebra 2. Now we want to talk about Algebra 1. Loading. All right, most of the stuff you guys need to know for my Algebra 1 peeps is about basically the slope-intercept form and just graphing lines. Those are going to be the big things that we're going to be talking about. The thing I want to talk about, let's see here. I want to pick a topic that will cover like kind of a lot of things at once. And I think, yeah, that will work as much as anything. We're going to talk a little bit about slope. Okay, so let's talk about slope. All right, slope is at it's most basic definition the slant of your line. So you're either going to be going up, you're going to be going down, you're going to be going straight across, or, ooh, that was terrible. Let me try that again. Straight across, or you're going to be going, nope, up and down. There we go. Each of these has a different things. The thing to keep in mind when you're talking about slope is that you read a slope like you read words from left to right. So if I am looking at this slope and I'm reading it from left to right, is it going up or is it going down? If it is, text box, if it's going up, it is positive. If it's going down, it is negative. And I cannot type because apparently I wrote these words backwards. Baka sensei. Yes, I know, baka janai da yo. All right, excuse me. The next question is, so read from left to right, it's positive. Read from right to left, it's negative. Completely flat, completely vertical. Those are different cases. So this is from my high school teacher. So we're really reaching back into the annals of history, okay? When Ms. Dubois was in high school in the dark ages of the 90s, my high school teacher would tell me, hey, slope is like skiing. If there's no slope, there's no problem because I don't mind cross-country skiing. That I can handle as an old lady. And I now, as Ms. Dubois, can tell you, I'm an old lady. Cross-country flat slope skiing, zero slope skiing, that I can do. If I'm going to be skiing off a vertical cliff, no slope, no way. That's the basic rule of thumb. And much like the quadratic formula, this particular math teacher, she told it to me once, and I could not unforget it. And so now you all must suffer the same fate. So you read from left to right, going up, it's positive. Read from left to right, it's going down, it's negative. Flat, 0 slope, 0 problem, because I can ski that. No slope, no way. I am not skiing off a sheer cliff. That's the big thing. There are, of course, formulas for everything because algebra, but the thing you want to keep in mind for slope is if they can't give you a graph, there's a formula for that, much like what I was just talking about for the quadratic formula for my Algebra 2 kids. So you have y2 minus y1. Nope. Wow. Text box is a thing. y2 minus, Lord in heaven, minus y1 all over x2 minus x1. And when I teach this to kids, a lot of them kind of look at me funny. They're like, what, how, what? Why is there 2's and 1's there? The horror, the horror. What they're actually doing is they are presupposing that you know 2 of the points. So I'm just going to make something off the top of my head, 7, 8. And we'll do, I don't even know, -6, I don't know, -3. I have no idea what I'm doing. I pick these numbers at random, so we're going to see how they suss out. The thing that you need to do, and you will hear me say this when you have this topic actually open, is eeny, meeny, miny, mo. Which one is your first point? Which one is your second point? That's the question you're constantly asking yourself. So, eeny, meeny, miny, mo. Which one is your first point? Which one is your second point? That's what you're trying to check. I will choose 7, 8, I choose you. You are going to be my first point. So you're x1, y1. All right. And then, what just happened? Sensei. Go there. Then, therefore, this is going to be x2 and y2. Well, what does this actually mean? You have all of the numbers pre-labeled, so now you're ready to actually set up the formula. So y2, let me look over, y2. Okay, there's my y2, so what's my number? -3. What comes next in the formula? The minus sign. So, minus. Next, y1 is what I'm looking for. So where's y1? There it is. What's the number? 8. There we go. See? Not much in the way of actual work. -3 minus 8 all over what? Let's see here. The first thing we're going to be looking for is our x2. So what's our x2? There's our x2. So what's the number? -6 minus, going to be x1. What's x1? 7. Huh, funny that. All right. So then what does that actually mean if we do that out? We need to keep in track our numbers, and I know for a couple of my Algebra 1 kids, signs are a thing. -3 minus 8. Those are the same symbol, which means we're going to be adding them. So -3 and -8 is -11 over what is -6 and -7? That's going to be -13. So that's a little bit awkward for a slow. Oh, wait, that simplifies. That simplifies, Miss Dubois. Look, they're both negatives. So that just becomes +11 over 13. There you go. So this is remarkably consistent in terms of a formula. If you can do it on a grid, so much the better. I know that that's actually visually quicker since this is rise over run, so you just count how many up or down, how many over, and that part makes sense. But the thing to keep in mind is that this can be done no matter what you are given. This formula is so versatile that you can either have any 2 random points on a graph or any 2 random points like they do here where they actually give you a topic. So let's see if we can pull out another example from the software. So, eeny, meeny, miny, mo, finding slope given 2 points on the line. So let's actually do one that the software will give us and see if that makes it look even remotely nicer to us. So controls. Find the slope of a line passing through points -6, -5. Isn't that exactly the point that I just did? -5 and then 4, 4. Copy, done, over, paste, transform, and let's make this a little bit big because that is shockingly hard to read. Move that down here. All right, we're going to scroll down a little bit and we're going to do some work. So there are our numbers. So now the question is, what's our first slope and what's our second? So I'm going to be mildly radical and say, hey, you know what? This is going to be our x2, y2, and then this one will be our x1, y1. Let's be really, really crazy here for a second. All right. Now, if we set up the formula, what's the first thing we're going to be doing? We have y2. What's my y2? Negative 5. Negative 5 minus, yoo-hoo, text box, do the thing. Negative 5, negative 5. Dear universe, save me from internet problems and text problems. Good Lord in heaven. What am I doing wrong? 18 sharp. Text is fine. So then what's going on? All right, fine. Okay, so what's our y2? Negative 5. Then it's going to be minus, now I'm all lost out and out of place, y2, negative, which is negative 5, minus y1, what's our y1? 4. All of that over x2, so what's our x2? x2 is negative 6, minus. A lot of kids, when they're first learning this, they're not used to writing that minus there, and what happens is they tend to get their signs a little bit screwed up. So be very careful. Write your minus first, and then look at the sign of your number. What's the sign of x1, which is 4? So what does this actually equal? Negative 5 minus 4 is negative 9, over, what's negative 6 minus 4? That's going to be negative 10, which simplifies to 9 keyboard, over 10. And let's see if we're right. If we go to explanation, will it tell us that we're right? 9 over 10. There it is. Now they did it a little bit differently. See that? They did 4 minus negative 5. So you do want to be careful with your signs. That's something that you want to keep an eye out for. All right? So that's this one. What's another good one? Identifying linear equations. Well, anything to do with slope, Ms. Dubois. Let's see here. Classifying slopes. Finding slope given a line on the grid. Now these ones are a little bit easier. You don't have to go through the effort of the y2 minus y1 over x2 minus x1. As useful as that formula is, because it's on a graph, we can do some counting. First of all, quick reference, read a graph from left to right. If I go from left to right, that's sloping up, so we know that this is going to be a positive slope. And now we count. 1, 2, 3 over 1, 2, 3, 4, 5. So our slope is going to be 3 over 5. I wish I had a pen tool that worked for this. 3 over 5. Let's see if we're right. Explanation. 3 over 5. And look, you can even see, even though it was on a graph, you can see that they were using that y2 minus y1 over x2 minus x1 in their formula as well to get them used to the fact that it doesn't matter which way you do it, you're still going to end up getting the same thing for slope. Let's see here, finding 2 points on a line. Finding slope, we did that one. Rewriting an equation in slope-intercept form. There are some other big ones here. Let's talk a little bit about slope-intercept form. That's going to be the next big thing. Y equals mx plus b. That's your slope-intercept form. Slope-intercept form. And much like the quadratic equation for Algebra 2 Goal 4, this is one of your hallmark formulas for Algebra 1 Goal 4. It's not quite as versatile as the quadratic formula in Algebra 2 because that formula is used practically in every topic. But here I can easily say that slope-intercept form is probably used in roughly about half of the topics. They are either getting you used to the format, they are forcing you to manipulate an equation to get it into this format, or they're outright giving you this format and expecting you to graph a line. Oh my God, I've been talking for an hour and I'm so parched. How am I going to do this for 3? So let's pick one of the topics. Let's see here. Classifying slopes. Somewhere. There we go. Loading. Ask her if she can still see us. All right, when we're looking at this one, line passes through the point 97, has a slope of negative 2/3. You can kind of see that they give you some of the information you want, but you don't necessarily understand what it is that they're asking. And this one can be a little bit tricky for some people if they're not quite sure how this goes. And this equation actually pops up again in Goal 1 of Algebra 2. So for those of you who are in Algebra 1, can't forget the topic. It's going to come back and bite you. So paste, transform. Let's make that a little bit more legible. So if we're looking at this one, text box, we're going to use that y equals mx plus b format. But if you notice, they didn't give us the right numbers. Like, they gave us the slope. You know that, oh, maybe I should explain that first. So m is your slope, and then b is your y-intercept. So shockingly, given that it's called slope-intercept form, that means you have a slope, and that means you have a y-intercept. Slope, y-intercept, slope, y-intercept, slope, y-intercept. How shocking, except not really. All right, so knowing that, what did they out and out tell us? They told us what our slope is. It's -2/3. But then the question becomes, okay, that's fine, but what's our b? They gave us some random point on the line. There's not a 0 in for the x. How does that logic? What do we do? So when you're looking at that, if you have your y equals mx plus b, well, if you actually think about that, there's a y and there's an x. And hey, look, there's a coordinate here. There's an x and there's a y. Funny that I'm beginning to think they're doing this on purpose. So we fill in numbers that we, in point of fact, actually know. So what is our y? 7, Ms. Dubois, keyboard, please be nice to me. 7 equals, what's our slope? It's going to be -2/3 times our point, which is -9 plus b. And when you look at that, there's only one variable, the b. That means we can use our algebra skills from chapter 1 to actually solve this and therefore make it easier. And here's the good thing about the software. This is the love part of the love-hate relationship with the software. They always give you fractions that will divide evenly with your x. And if you're any good at fractions, you know, like a certain human calculator who's talking right now, you can actually use that to your advantage. So I'm going to look at my x, and I'm going to look at my denominator, 9 and 3. 9 and 3. It's technically 9/1, which means 9 is on top and 3 is on bottom. What's 9 divided by 3? 9 divided by 3 is 3. So what that means then, if it's 9 divided by 3, oh wait, I'm not done yet. You have 9 divided by 3, which is 3 times 2. Negative times a negative is a positive. So what that does is that leaves us with 3 times 2, positive 6 plus b. Funny that. And of course, you know, if you're lazy, I suppose you can use a calculator. Oh, I'm sorry. Was my sarcasm showing? For those of you who aren't comfortable with your mental math, or maybe even now after all of the practice, the fractions still kind of wig you out a little bit. I'm not going to blame you for not using a calculator. It's just eventually, especially when you get into the junior, senior level math, you're expected to be able to do some of this math at least a little bit in your head. I don't mind if it takes a while, but I do mind that you can do it in your head, because some of these topics you're not going to be allowed a calculator for. So, numerator, divide. So 9 divided by 3 is 3. Then take your answer and multiply it by your numerator. 3 times 2, which gets us the 6. And now we have our basic setup. So now we just solve, because it's a one-step, minus 6, and then minus 6. And what are we left with? 1 equals b. Computer. There you go. 1 equals b. So when all is said and done, y equals mx plus b. Well, what does that mean? Y equals -2/3 x plus 1. Let's see if we're right. So -2/3 x plus 1. That's what we need to remember. So if I go to explanation, hey, look, it's the exact stuff we did. Plug in the -2, put in the -9. Do our magic math. 9 divided by 3 is 3, times 2 is 6. Subtract 6 from both sides. They never show you that in between step. B equals 1. Look, -2/3 x plus 1. How does that logic negative? Yep, -2/3 x plus 1, -2/3 x plus 1. Ta-da! There we go. What else can we do? Writing an equation of a line with 2 given points. So if you have that y equals mx plus b, let's really take it about as far as we can push it. Now this is challenge mode. This is giving you, come on, load. No, is that it? Given 2 points? I thought there was one where they gave us 2 points. Maybe I was wrong. Yep, okay, it was this one. So look at that, challenge mode activated. They don't even give you the slope and they expect you to find y equals mx plus b. The horror. Ms. Dubois, what do I do? Dosio, panic janai desu. All right, so what we're going to do is we're going to copy this down just so I have something to reference. So copy, done, tab, paste, transform, and now let's make this as big as humanly possible so that we don't freak out when we see it. There we go. When you're looking at this one and you're looking for that very versatile y equals mx plus b, it's hidden completely from view. It's almost MIA. And your brain is kind of looking at that and saying, what? How? Logic? What? So what we're going to do, if we have y equals mx plus b, we're actually going to be using both of our formulas because you also have y2 minus y1 over x2 minus x1. All right, so with that in mind, how do we use these two things? The first thing that we need more than anything else is this. If you remember, m is your slope. That's the thing we got to find first. And yet again, they gave us 2 points. So all we actually have to do is go through the effort of labeling which one is my first point, which one is my second point. So I'm going to assume that this is x1 and then our y1 and then y1 Ms. Dubois, and then I'm going to assume that this is our x2 and our y2. Didn't give myself enough space. x2 and y2. Computer, be nice to me. There we go. All right, so with that in mind, we're actually going to start with Fizzwidget, Schnitzel, Jiminy Cricket. There we go. We are going to start, there we go, with our slope. So what is y2 minus y1? So y2 is going to be negative 2 minus y1. It's going to be y1. So what's labeled as our y1? Oh my lord. I did a garbage job in typing this, didn't I? I hope no one's getting confused as they're looking at this as I flail incoherently and try to make this work for myself. Okay. Text. There. Negative 2 minus, what was our y1? Our y1 is negative 6. Okay, so we want to be careful of that. It's minus a negative. What happens when you minus a negative? It becomes a, somebody tell me. Please tell me. Okay, we're going to assume it's a positive. Then it's going to be x2. What's our x2? It's 5 minus, what's our x1? Negative 1. They did it to us again. Double negative is a positive. Tab. Okay, so computer, there we go. So negative 2, that's a negative, right? The negative is too small. Mine would be that way. Negative 2 plus double, so double negative is a positive, double negative is a positive. Drill it into your brain. Double negative is a positive, double negative is a positive. Negative 2 plus 4 is 2 over negative 5, or no, 5, excuse me, 5 plus 1, which is 6, and all of that simplifies to 1 over 3. Okay, half the work has now been done. We have a slope, so we now know that it is going to be y equals 1/3 x plus something. We don't know what yet. Except we totally do because we just did that in an earlier topic. So again, for those of you who have my outlines when I do them, you want to do this topic first before you do this topic. You want to do this topic first before you do this topic. It all kind of builds into each other. So just picking at random from the carousel, maybe not a good idea. So what do we have? We have a y. Well, actually, we have 2 of them. So now we have choice time. Eeny, meeny, miny, mo. Which point do I want to use to find the y-intercept? And here's the glory of this. It does not matter. When I say eeny, meeny, miny, mo, I really do mean eeny, meeny, miny, mo. So let's just try the first points just because they're labeled as ones, which means they're number ones. You know, let's see here. So it's going to be, what's our y? Our y is negative 6 equals 1/3 times, what's our x1? -1. Oh, that's going to be a nightmare to do. Okay, plus b. All right. They gave us fractions, universe. Beware, they gave us fractions. And I can hear all of my Algebra 1 kids banging their head against their keyboard saying, Miss, no, the horror. But we're not going to let it freak us out. Because what we do, we're going to simplify this again. So -6 equals -6, Miss Dubois, equals -1/3 plus b. All right? So we're adding 1/3 to both sides. So plus 1/3. And then over here, it's going to be plus 1/3. All right. Again, for those of you with the calculators, be careful of your signs, but you can do this. For me, again, the human calculator, I happen to know that that's a whole number and I'm only taking a third out of it. And when I take a third out of a whole number, it's going to be 2/3. And I'm only subtracting the 1 by the 6, which means I'm going to have 5 and 2/3. All of that is going to be negative over equals b. So for this topic, and FYI, this topic, what's the title of this? Writing an equation of a line given 2 points. This is a DSA topic. This is on, I think it's 4.2 when you take your DSA. This is a DSA topic. All right. So you're either planning, Miss, this is going to be the one I get wrong. Or it's going to be like, wait, Ms. Dubois taught me how to do this. I think I can manage it. So if I actually do this out, if that's my B back over here. Oh my Lord, this thing does not like me. Photoshop, you're usually so nice to me. Tab, text, click, there we go. So what are we left with? Y equals our slope, which is 1/3 x, and then what's our y-intercept? -5 and 2/3. Let's see if we're actually right. So 1/3 x minus 5 and 2/3. So they might give us 17/3. Let's see, 1/3 and then 5 and 2/3. So explanation. 2/3. Ms. Dubois made a math mistake. She proved herself fallible. The horror. Why is it 2/3? 2/3 negative. It's a 4. So what did I end up getting? A 2. Wow. Wow. Ms. Dubois and math. Double negative is a positive, which is going to be -2 plus 6, which means it's 6 minus 2, which is supposed to be 4. Did Ms. Dubois write that? The horror, the horror. Oh my Lord. Which means that's going to be 2/3. All right, so if this is 2/3, and now everything cascades down. Oh, that makes finding mistakes so annoying. Which means that's going to be 2/3, which means that's going to be 1/3. So it's going to be -5/5 and 1/3, and that's going to be 16/3. And is that what they gave us? 16/3. Yeah. Okay, so keep in mind of your signs, and apparently don't trust the human calculator to human calculate on a coronication. Life moves on. What else can we do for Algebra 1, Goal 4? Something that is slope-intercept related. Writing the equation of a line given the y-intercept and another point. Is that the one I'm thinking of? Some of the some of the topics in Algebra 1, Goal 4 tend to blend together after a while. Okay, I know that. Is it always a graph format? Yes. Is it always a graph format? Yes. So here is where the y-intercept form comes into play again. Because again, text box of doom. Because again, I cannot emphasize this enough. Caps lock, y equals mx plus b. So once you know that kind of formula and you've sort of like mentally internalized it, then you can look at a graph like this and say, oh, I know what I'm doing because it's y equals mx plus b. I need to find my m, but the b, the y-intercept, oh my god, there it is right there, plain as day, clear as crystal. So we know that our answer is going to be y equals something x plus 3, and I say plus 3 because it crosses the y-intercept at actual 3. How wonderful. The question now becomes, what is the slope? You can do it the long way. For those of you who have trouble finding slope, you can do it the long way, so you can do the counting. 1, 2, 3, 4, 5, 6, 7 over 2. You can also do it if your mental math, again, this is if your mental math is strong. I go from 7, 1, 2, 3, 4, 5, 6, 7, 8. That's what I thought. I'm jumping from 5 to 3. And if my mental math is really strong, I know that I'm traveling 8 and I go over 2. So what that means is that my slope is going to be 8 over 2. Is it positive or is it negative? I'm looking up here. I'm reading it from left to right. That means it's going to be positive. So then, does 8 over 2 simplify? Yes, it does. Y equals 4x plus 3. Ym? What the heck, Mr. Blah? Y equals 4x plus 3. I can type! Aren't we doing wonderful? All right, so explanation, let's see if we're right. So we found out that the b is 3. That makes sense. It was pretty obviously splattered right there, red dot, easy to point out. And then rise over run. So we went, they do it a little bit weird here because it's rise over run. It is how far up and down over how far left and right. But what they do here is they kind of lead you to being right over 2 and up 8. And I'm not comfortable with that. And that's the hate part of the love-hate relationship with the software. When you're trying to train a student to get them used to doing something a certain way, that means you have to effectively demonstrate it a certain way. When I was doing this just now, you saw me. I counted. I went up 8. My rise is 8. My run is 2. And then 8 over 2 simplifies, like they say here, to 4. 4x plus 3. 4x plus 3. Yay! So now we got to pick another one while I sip for my water. Let's see here. There are easier topics that get you comfortable with y equals mx plus b. Think of them as starter levels. So, of course, they give you a trick question right off the bat. Put that on pause. I'll get back to that one. So if you're looking at this one, what is the y-intercept and the slope of a line? You're only identifying two numbers. You have a number here in front of the x. You have a number there in front of, or after the x, the one that has a number by itself. Based on the notes that we have been taken, boop, there it is. Let me zoom in so you can see it without all the distraction and the clutter. Mx plus b. M is your slope. B is your y-intercept. M is what's in front of the x. So what's in front of the x? -1. Y-intercept is b. The y-intercept is the number by itself. There's your number by itself. So our slope is -1 and our y-intercept is +1. Are we right? Y-intercept 1, slope -1. Huzzah. Let's show another one. Oops, I gave the game away. Wait, back. Stop, go away. Problem, there we go. This one is kind of a trick question that they tend to throw at students, and if you looked at the explanation, they kind of gave the game away. The slope is really easy. The slope is the 1/2 because m, your slope. Your slope is your m. It's the number in front of the variable. It's the number in front of the variable. Did they give you the y-intercept? There's nothing after the fact here, but what does that imply? Well, what's your placeholder in numbers? 0. And when you look at the explanation, there it is. It gave the game away. +0. There's our b. Our y-intercept is 0. And once in a while, they will throw in a second flavor. So this would be a second flavor. It's a trick question where they're trying to trip you up. But you know what you're doing because, again, y equals mx plus b. M is your slope. B is your y-intercept. And now we learned if they don't show you anything, then you know what the y-intercept actually is. Let's do another one. Loading. Now here they try to trip you up again because now the numbers are out of order. You're so used to the mx plus b, the m is being first, and some kids get a little bit tripped up, but the most important thing is that the m is connected to your x. So which one here is connected to my x? The -6. So our slope is -6 and our y-intercept is 5. Let's see if we're right. Slope is -6, y-intercept is 5. Huzzah, we got it right. And I think this one has a third type. I think 1, 2, 3. There's your slope. Slope is 5. Y-intercept is -1. Slope is 5. Y-intercept is -1. Okay. And then no, it looks like they only have the two types. Okay, so in review for this particular topic, there's your slope because it has the x. There's your y because it is the number that does not have a variable next to it. They try to trip you up in moving the order, or they try to trip you up by giving you a y-intercept of 0. But we've now covered all of those different permutations, and you know what to do from there. What happened? Where'd my topics go? Let's see here. What's another good one? Equation of a line through 2 points we did. if this is the one I'm thinking of, because now that we know about y equals mx plus b, I want to talk word problems a little bit. Here we go. Aha. And I already hear my Algebra 1 kids groaning, Miss, I hate word problems. The horror, no. But here's a little trick for word problems. Let me get this over into Photoshop. Copy. Scroll down to the bottom. Zoom out a little bit. Paste. Tab or transform. All right. This is honestly the easiest topic in terms of word problems. I think it's this one. Everyone looks and sees words and they think, but because you have, again, y equals mx plus b, those things mean more than just slope and y-intercept. So y equals mx plus b. If m is your slope, what does that actually mean? If b is your y-intercept, what does that actually mean? Slope, in point of fact, actually means that is your rate of change. So the question that you are constantly asking yourself is, how is this changing? So the base salary is $1,600, makes an additional $50 for every copy of English is Fun that she sells. So for every, the key words you're looking for is for each, per, and for every. The minute you see those words, look for the number that's attached to them. That is your slope. For y-intercept, there are a couple of words for those, but the most obvious, this is your starting point. That's the whole point of a y-intercept. It crosses your y-axis, and in real world, that's your base. Oh, there's a word for that. It is your base, or sometimes it's called your start. There are a couple of other keywords. As we find them and go through the examples, I'll list them as we go. But when you're looking at that, if you know what your rate of change is and you know what your starting point is, I'm sorry, Ms. Leavenworth, you're cringing, I know. Your starting point, your base, your start, etc. Once you know that, then you're set up in order to know how to set up your equation. So if we're looking again for the y equals mx plus b, we now know what number goes where. Y equals 50x plus 1600. That suddenly and I didn't even read the whole problem, but because I knew what my keywords were, I knew my base was my starting point, i.e. my y-intercept. I knew that it said for every, and that's one of my keywords for rate of change, aka my slope, my x. The only question now is, instead of using y and x, they very deliberately want you to get used to using different letters. This is the hate part of the love-hate relationship because the wording of this is a little bit awkward. Let P represent her total pay, N represent the number of copies. This actually, in context of this one, it makes sense. There's a weird one in one of the permutations of this topic where, like, it's not immediately obvious, but P is your total pay. This is all about what you're taking home. That means that's what you're ending with, your P equals 50N plus 1600. Once you know one, you know all of them, right? The other thing to look at if you're looking to do it the cheap and lazy way is P, the first letter they give you, is always going to be your Y. I don't really want to admit that that's a shortcut, but I do live in the real world and some kids are going to not bother reading this in its totality, which is unfortunate because actually thinking about what does P represent and what does N represent, all it takes is an extra 2 to 3 seconds and then you can figure out which one's your Y and which one's your X. But this is our goal, 50N plus 1600. Let's see if we're right. Explanation. And again, love-hate relationship with the software. I get why they explain it this way, but that's not my favorite. Because once you know what your keywords are, once you know that for every is your slope, once you know that base is your salary, it becomes a lot easier. And are we right? 1600 plus 50N. Yes. And then the last thing they ask is total pay if it's 22 copies. 22 copies? Well, gee, since N is the number of copies, we just plug 22 into the 50. So 50 times 22 is going to be 1,000, and then the 2 is going to be there. So it's going to be 1,100. 1,100 plus 1,600 is going to be 2,700. Yes, I just did that in my head. Don't at me. So let's look at another one. Let's see here. Show another. All right, starting length is 54 miles. The crew is adding 3 miles to the road each. There's that key word again, each. What does each represent? If we go over here, each, there it is. It's the rate of change. What's the number attached to each? 3. 3 is my x. Boom. I didn't even read the problem. So 3x plus, what's our other number? 3x plus 54. Y equals 3x plus 54. Only they don't want x and y. L equals 3D plus 54. And then they want 34 days. All right, so let me write this down before I forget it. So L equals, again. L equals 3D plus 54. Capital D, Ms. Dubois. I don't know if the software nitpicks, but just in case. 3D, and then we want it to be 34 days. So L equals 3 times 34 plus 54. 3 times 34 is 90, 102. 102 plus 54 is 156. L equals 156. Let's see if we're right. Huzzah! 156. I'm smart. Big brain. Did you hear that, Kevin? Big brain. Oh, wait, I'm not supposed to shout out a student name. Oh, sure. I'm in trouble. L equals 54 plus 3D. Is that what we have? 3D plus 54. Commutative property of addition. We're fine. That's another thing. Order doesn't matter. You don't have to do 54 plus 3D. You can do 3D plus 54 because you're still doing the same order of operations. Hoo-ha. And then it's times the 34, and we get 156, and we get 156. There we go. One more problem to make sure you guys are comfortable with it. What time is it now? 11:30, and I'm a little bit nervous right now because my fam on my laptop is shouting at me saying, Ms. Dubois, you're overworking me. What is wrong with you? And I might have to cut off the live stream early. We will see. So, show another computer. Okay, so starts, there it is. Starts, I don't even need to read the rest of it. My eyes just jump to that word. Starts is 450. Which one is starts? Starts is my y-intercept. So it's something plus 450 each week. Each is which word? Each is my rate of change. That's my slope. So each is 40. So y equals 40x plus 450. Again, did not read the problem. Maybe I shouldn't be saying that out loud. I just realized how just arrogant that sounds. Let S represent the total number. So S equals 40W 40W plus 450. So I got to write that down because I won't remember it. So, oh, my Fizz widget. What was it? I don't even remember. S equals. Ugh! Dear computer. S equals, what is it? 40x plus 450. That means 40W. 40W plus 450. And what number are they actually looking for? What did they tell you? 14 weeks. All right. So it is going to be S equals 40 times something plus 450. And what was the number? I don't even remember from one second to the next because I'm old. 14. So 14. Okay, 40 times 14 is 40, 52. 450 plus 52 is 502. That is going to be, I ran out of room here. So S equals 502. Let's see if we're right. Computer, I know you're mad at me. 1010. Wow, Ms. Dubois cannot math for shiznits. All right, 14. 40 times 14. So that's going to be, because it's 400. It's going to be 410. 400 and, oh my lord. All right, Ms. Dubois needs to math for a second. Stop, bad, escape, text. What is 40 times 14? So 40, so that's going to be 400 plus, what's 4 times 4 is 16, no. You hear the squeaking wheels in my brain? This hurts a little bit. 10 times 40 is 400. That makes sense. Is 1, 6, no. Yes, it's 160, which is 560, and then I added to the 450, which is 1010. Yep, I'm an idiot. Okay, my big brain disappeared and I went small brain. For those of you who are always goggling at the fact that I'm the human calculator, this is the computation that I'm doing really fast in my head. I did 1 times 40, which is 400. I did 4 times 40, which is where I gobbledygooked, and it's 160. And I thought it was 12, and we're going to laugh at me later. Nissan! That was my sister. So 400 plus 160, which is going to be 560. 560 plus 950 is going to be 1010. So Sensei no Baka. All right, my computer is shouting at me. Like, I don't know if you can hear it on the mic, but the fan on my computer is about to blow its mind. I'm going to end the live stream, God, way earlier than I wanted to. If this works and I can set it up again, I'll have another live stream tomorrow, and it'll be a lot more planned out and organized. I was more focused on making sure that the live stream could actually work. Since Luddite that I am, even when I'm painting, I have never live streamed. All right, so where we're at right now, day 1 of the Karunication. I have given you guys the most important formula in all of universe for chapter 4, algebra 2, and I have given you the 2 most important formulas for algebra 1, goal 4. That's the where majority of my students will be able to handle a lot of topics, and then tomorrow I will be infinitely more, yes, computer, I know, I will be infinitely more organized. I will see you guys tomorrow. Thank you kindly. Stay safe. Smile. Enjoy the